Welcome everybody to 5.1 Rate of Change and Slope. So today we're going to go over two standards, FLE2, which is constructing linear functions, and SID7, which is interpret linear models. And today we're going to learn how to find slope, which is your rate of change, and your y-intercept, which is initial value, given a graph. Okay, so let's look at the first one. So according to the first graph, how fast is it going? We're going to zoom in. So how fast is it going? If we're given distance in meters, time in seconds. So we calculate that, can we figure out how fast is it going? So we start here and we go 10 meters for every 5 seconds, right? So 10 meters, 5 seconds. And that'll be our rate of change, right? 10, 5, 10, 5. And just keep going up. 10 meters, 5 seconds. 10 meters, 5 seconds. 10 meters, 5 seconds. And that would be our rate of change, right? So 10 meters for every 5 seconds. And if divide that, 10 divided by 5, it's going to be 2. So 2 meters per second. And that's our speed. And this is our rate of change. Okay, for the next one. How fast are these going? So you got distance in meters and then time in seconds again. So let's look at the blue line first. So looking at the blue line, we start here, 0, 0, and we're going to go until we get to a solid point corner right there. So we stop right here. So other ones we cannot tell where it's at. So we go to a corner and then we count it. So 1, 2, 3, 4, 5. So 5 meters, and you go this way, 1 second. So the blue one is going to be 5 meters for every 1 second, which is 5 meters per second. Yeah, that's the blue one. Then the red one, same thing. We're going to go until we hit a corner right there, and then we calculate it. So we go up 2, right? So 2 meters, right? 1 second. So this one is 2 meters for every 1 second, which is 2 meters per second. Right there. Bam. That's the red. Okay, what about this one? So we're given distance in kilometers, time in hours now. So we look at the green one first. So we start the green, 0, 0, go till we hit a corner right there. And then we count it. So it goes up 20, and this is kilometers, and then right 1 hour. So our speed for this one, 20 kilometers over 1 hour. Divide that, you get 20 kilometers per hour. That's the first one. Second one, go red, and we're going to go until we hit a corner. It's right there. It's right there. So we'll go up 10 kilometers, right 1 hour. So this is 10 kilometers over 1 hour, 10 kilometers per hour. That's for that one. Right, these two. Okay, there's no labels, there's no units. That's okay. We still could do it. Okay, so let's look at this one. Starts at 5, and we go until we hit a corner. Right, here's a corner, and then we count. Right, so it goes up 2, goes right 1. Right, it follows the same pattern. Right, 2, 1, 2, 1, 2, 1, all the way up. Right, so our rate of change is going to be 2 over 1 or just 2. Right, that's our rate of change. right? And our rate of change is also called our slope, right? So when you hear rate of change or slope, it means exactly the same thing. Okay, for a second one, start at 9, and then we're going to go down. So we hit a corner, which is right there. Then we're going to count. So now we're going down, right? So 1, 2, 3. So since we're going down, it's negative. Negative 3, 1, 2. Positive 2 to the right. And we're still going. Negative 3, right 2. Negative 3, right 2. Right? So our rate of change is negative 3 over 2. Let's leave it as a fraction. Right? So that's our rate of change, which is also our slope. Okay, so for this section, we're going to start off with the slope-intercept form, which is f of x equals y, or f of x equals mx plus b. Right? That's our slope-intercept form. Our coefficient m is a slope, which is our rate of change. Our b is a y-intercept initial value. So we're going to do a lot of this function. So we want to get used to it. So f of x equals mx plus b. Our m value, whatever is next to our x variable, is our slope, which is our rate of change. Okay? And whatever is at the end, our single number, is our y-intercept. And it's also our initial value. So initial value. So whatever start with, that's our initial value. Yeah, to add on to this. So let's apply it to some problem. So if we had, let's say, cost per hour, right? Cost of h per hours equals, say, 50h plus 200. So relating that to our function, our slope-intercept form, right? Whatever is next to our input value, which is the h, this number right here is our slope or our rate of change, right? So this is our slope, which is the rate of change. This number is our y-intercept, which is our initial value. Okay, so when you find out what is the cost for a certain amount of hours, we know that the initial cost is $200. So something costs us $200. The rate of change is how much it charges. So like charges $50 per hour. So that's how much it will cost. So it'll cost $200 initial value, and then you're adding $50 per hour, $50 per hour. So that's how you relate y equals mx plus b and any other linear function. Right, so $200 initial cost. This one will be $50 per hour. And then slope of a line, right? Positive goes up to the right. Negative goes down to the right. 0 is flat ground. Undefined, straight up and down. Kind of go up and down. That doesn't make sense, right? And you can use slope map. Okay, so our slope, rate of change, is given by change in y over change in x, which is y2 minus y1 over x2 minus x1, which is also your rise over run. So that's going to be our slope. Yeah, so for this one, we're going to find what is the slope and y-intercept of each line. To do these, we're going to start at the y-axis. So here's our y-axis right in the middle. Right, we're going to start wherever that intersects. So right here is where we start at, and this is down 1. So this is negative 1. So our initial value, or our y-intercept, is negative 1. Yes, we're going to put negative 1 is our y-intercept. Then we're going to go to next point right here to find the rate of change or our slope. Right, so we go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And just keep following the pattern. So our slope equals 1 over 1, which is just equal to 1. So our slope is 1. Okay, number 2, we're going to start on our y-axis again, and this is at 1. So our y-intercept is 1, and then we find out what is the slope, right? So rise is nothing. So it's going to be 0 over 1, right? 0 over 1, 0 over 1, 0 over any number, it's still going to be just 0. So our slope is 0, which is flat ground, right? Flat ground is always slope is 0. Okay, number 3, same thing. We start at the y-axis, figure out where that is. That's -2. Our slope, we're going down now, so we're count 1, 2. So that's -2, right 1. That's 1. And we keep following -1, -2, right 1, -2, right 1. So our slope is given by -2 over 1, which is just -2. Okay, let's do number 4. So y-intercept right here, that's in the middle, so that's 0. Then it's going down to the right, so it's going to be negative. So we go until we hit a corner right there, and we count. So down 1 is -1, right 2, +2. Down 1, right 2, right? And if you continue on, it'll go right here, down right 2. So our slope is down 1, -1 over 2. So that's just going to be -1/2. So our slope is -1/2. Okay, and that's all there is to it. So start the y-intercept, use your rise over run to find the slope, and you can do the rest of the problem, and you get 2 Katacamis.